Hello everyone, my name's Ty Haig. The topic that I chose to research for this project is gas dynamic lasers, specifically combustion-driven gas dynamic lasers. These are a very, nowadays, kind of a niche laser. There's not a whole lot of research happening with them currently, but they were researched heavily in the 60s and 70s, and they're a personal interest of mine. So hopefully this can be insightful into this niche type of laser for all that listen. So to understand a gas dynamic laser, we need to understand some of the basics of a laser. Laser is an acronym. It stands for light amplification by stimulated emission of radiation. So essentially in a laser, you have a lasing medium in which population inversion between energy levels occurs, and then you can use this population inversion to create stimulated emission of light that is coherent and spectrally pure. So most lasers nowadays are what's called a four-level system, and that's just referring to the type of quantum arrangement that the laser uses to create lasing. Some of the different lasing mediums, most common are crystals, dyes, semiconductors, and then gases as well. And then a gas dynamic laser, of course, uses a gas as its lasing medium, specifically CO2 that is vibrationally coupled with nitrogen. So different methods of pumping a lasing medium to create population inversion. There's electrical, chemical, optical, nuclear is also one, and then in the case of a gas dynamic laser, it's the what we're interested in is thermal pumping, which is far less common or heard of when it comes to discussion and research in lasers. And the way you thermally pump a gas dynamic laser is through adiabatic expansion of hot gases through a converging diverging nozzle. So if you have high pressure, high temperature gases that are forced through a nozzle, once they get to the other side of the nozzle and are expanded, they go into supersonic flow, and they rapidly drop in temperature very quickly, and that's why this is called adiabatic expansion. You can use this quick cooling of the gas to create a population inversion between vibrational states of this carbon dioxide, and this population inversion can be used to create a laser, as with any other type of laser. So in the case of a CO2 laser, the wavelength output is 10.6 and 9.6 micrometers, which is far into the infrared region. This is kind of a three-level system. You can kind of think of it like that, but quenching isn't a problem because the ground level is just continuously flowing through the nozzle. So our lasing medium is actually moving very rapidly, so quenching is avoided. So here's a picture of and a schematic of a gas dynamic laser. You just have a combustion chamber on the left, a nozzle that the gases flow through, a diverging nozzle where they're expanded, and then you have a laser cavity to use the population inversion of the vibrational states of CO2 to create a laser output. This picture on the bottom right shows the scale that some of these combustion-driven gas dynamic lasers have been made at before. These are very large lasers. So what's interesting about a gas dynamic laser that's driven by combustion is your source of energy is burning a hydrocarbon instead of having a laser that's pumped by another laser or a laser that's pumped through a power supply. It's entirely a thermal process that's done through combustion, which is interesting because you don't have to plug it into a wall. You don't have to have electricity running one of these to get a high laser output. They can be used with different fuels and oxidizers as well. Um, Experiments have also been done with a gas dynamic laser and a shock tube. I bring that up because I know there's some students in the class who work with shock tubes, so hopefully that's yeah, interesting to you. These lasers, they've made them up to 1 megawatt. Yes, I said that correctly. These lasers have been made up to 1 megawatt of continuous power, which is incredible to think about. That is higher than, yeah, pretty much any. I don't think you can get a fiber laser up to that power with current technology. I think chemical lasers have been made up to that power before, but for these lasers in the 1960s and 70s to be made up to 1 megawatt is just incredible, even by today's standards. Yeah, there's difficulty in designing the laser cavities of a gas dynamic laser because um, yeah, you have different thermal effects because of the hot gases and the adiabatic expansion and the combustion that make it difficult to design the reflectors in a gas dynamic laser cavity, but there's ways around that. This slide kind of outlines some of that. So yeah, as I was saying before, you can get a 1 megawatt gas dynamic laser. That's been done before. And I bring that up just to show you the potential of this type of laser and how high power these things can get. Yeah, 1 megawatt in mechanical work is about 2 4 GTs. So if you think about that level of energy in a laser beam, or I should say that power in a laser beam, yeah, that's incredible to think about. So these are high power. You can use different fuels. You don't need an electrical power supply. They're efficient. The wavelength they output transmits through the atmospheric air very well. So there could be application for these in directed energy. Those are some of the big advantages of a gas dynamic laser, but there's also significant disadvantage of these, which is designing nozzles and laser cavities and different optical components to work with far infrared light. And these things are difficult to design when you're in a combustion environment. They're also quite large, and those are just some of the main disadvantages. Yeah, since the 70s, there's hardly been any research of these, which I think is a shame because they're super cool. They just kind of got phased out by other types of lasers. Are these types of lasers dead or just dormant? I don't know. I hope they're not dead. I hope they come back. I hope some more research is done on them. I think there could be lots of interesting applications to them, some of which are listed here. I think a gas dynamic laser could be of use in yeah, different applications. It's important to note that these applications I have listed here are not things that people are researching for the most part with gas dynamic lasers. These are just things that I think they could be applied to or I think are worthy of research, but that's purely my opinion. And then here are some different references. Thanks for listening.